For over a century, we've studied the sun. We've captured its flares, mapped its magnetic fields, and tracked its storms. But there's one place we've barely seen: the sun's poles. And they might hold the answers to mysteries that have puzzled scientists for decades. Nearly every satellite and telescope we've aimed at the sun observes from the same narrow band, the ecliptic plane, where Earth and most planets orbit. This means the sun's polar regions remain largely unexplored territory. And that's a problem. Because while the sun's mid-latitudes are busy with sunspots and solar flares, the poles quietly orchestrate something far more fundamental. They're the control center for the sun's magnetic cycle, the birthplace of the fast solar wind, and a critical piece of the space weather puzzle that affects us here on Earth. Mystery number 1. How does the solar dynamo actually work? Every 11 years, the sun's magnetic poles flip. North becomes south, south becomes north. This is driven by a dynamo process involving the sun's rotation and internal circulation patterns. But after decades of study, scientists still can't agree on the details. The polar regions hold crucial magnetic field data that could finally crack this code. Mystery number 2. What drives the fast solar wind? This supersonic stream of charged particles originates from massive coronal holes at the poles and fills most of interplanetary space. But we don't know if it comes from dense plumes within these holes or the spaces between them. And we're still debating whether waves, magnetic reconnection, or both accelerate these particles to such incredible speeds. And mystery number 3, how do dangerous space weather events propagate through our solar system? Coronal mass ejections can trigger geomagnetic storms, damage satellites, and even knock out power grids. But viewing them from the ecliptic plane is like watching a hurricane from ground level. We need a bird's-eye view to track their true path and predict their impact. Scientists recognized this problem decades ago. In 1990, the Ulysses mission became the first spacecraft to leave the ecliptic plane, sampling the solar wind above the poles. It confirmed key properties of the fast solar wind, but couldn't take images. Today, the solar orbiter is gradually tilting its orbit and will reach about 34 degrees in a few years. Impressive, but still not enough for a true polar view. Multiple ambitious missions have been proposed over the years, from solar sail concepts to complex gravity assists, but none have launched. Until now. Meet the Solar Polar Orbit Observatory, or SPO. Scheduled to launch in January 2029, this spacecraft will use a Jupiter gravity assist to swing out of the ecliptic plane and achieve an inclination of up to 80 degrees, giving us the first true view of the sun's poles. Over its 15-year mission, SPO will repeatedly pass over both poles, with observation windows lasting more than 1,000 days. It will be operational around 2035 when the next solar maximum and expected polar magnetic field reversal occur. SPO carries an impressive array of instruments: magnetic imagers, ultraviolet and X-ray telescopes, coronagraphs extending out to 45 solar radii, plus in-situ detectors to sample the solar wind directly. Working in concert with a fleet of other solar missions, including Solar Orbiter, the Solar Dynamics Observatory, and upcoming L5 missions, SPO will enable nearly complete 4-pi coverage of the sun for the first time in human history. The sun is our closest star, yet it remains mysterious. With SPO, we're about to unlock secrets hidden at its poles for all of human history. This isn't just academic curiosity. A better understanding of the solar dynamo means improved solar cycle predictions. Insights into the fast solar wind will help us model the space environment for spacecraft and astronauts. Enhanced space weather monitoring could protect the technological infrastructure on which our modern world depends. The countdown to 2029 has begun, and when SPO reaches the poles, solar science will never be the same.